Hi, welcome back to Mr. Slover's Math. Today we're focusing on proportions. So yesterday we saw what a ratio was, which was just a fraction, and that's what we're looking at in the warm-up. So what is the ratio of bananas to apples? So bananas, it says there's 11. Apples, it says there's 14. So notice my ratio is not the first number that I see in the sentence. It's specific to bananas to apples. So that's why I set it up as 11 over 14. And then I can leave it just like that. Number 2 is a unit rate. It wants to know how much she gets paid per hour. So I actually have to divide out what I have. So Howard gets $19 an hour. Now today we are focusing on a proportion, which is an equation in which two ratios or two fractions are set equal to each other. So example 1 says identify the following as either a ratio or a proportion. So it's just getting our mind set on what the difference is. So if it's just one fraction, it's a ratio. So that's why letter A and letter D are marked ratios, just one fraction. Letter B and C are two fractions that are equal. So I have an equal sign, I have an equal sign. Those are my proportions. Right, so that's the difference between ratio and a proportion. To determine if two ratios are equivalent or proportional, you can. So we're not going to do a whole lot with this, but you may in your geometry class next year, or potentially even in your Algebra 2 class in your junior year. So to determine if two ratios are equivalent, you are going to cross multiply, or you can simplify each ratio, or you can divide each ratio. So you have three options to determine if something is proportional or if it's equivalent. Now you don't have to do each option. You pick the one that works for you. So this is my notes answer key. So that's why I went ahead and I showed each one on the next example. But you get to choose which one you want, whichever one you think is the easiest. So I'm using, this is my example. And just like I have denoted in red, you only need to use one method. I'm just showing you all three. So if I were to cross multiply, so 4 times 24, and I'm showing my work here, equals 3 times 32, I get the same number. 96 equals 96. That's a true statement. It's the same. If I simplify my fraction, 4/3, leave it as an improper fraction. Don't turn it into a mixed number. Leave it as an improper fraction with your numerator potentially larger than your denominator. And then I reduce the other fraction. 32 over 24 becomes 4/3. They're the same. Or you can divide these out. 4 divided by 3 and 32 divided by 24. No matter which option you choose to see if something is proportional, it will give you the same answer. So all of these were true statements. They're not all the same number. 96 is not the same as 4/3, is not the same as 1.3 repeating. But these two, 96 equals 96. 4/3 and 4/3. 1.3 repeating, 1.3 repeating. So those are the same. So this example is proportional. If the numbers were different, then they would not be proportional. So if we look at example 2, this one is not proportional. If I reduce my fractions, 3/5 is not the same as 2/5. Or if I decided I wanted to cross multiply on this one, 20 is not the same as 30. Or if I decided I wanted to divide, 0.6 is not the same as 0.4. Okay, so once again, you only need to do one of the options, whether it's reduce your fraction, whether it's cross multiply, whether it's divide them out to become decimals. I'm just showing you all the options. So now that we kind of know what something is, if it's equivalent, if it's equal, let's go ahead and actually solve our proportion. So if we have a proportion that is equal, we are going to cross multiply. So we're going to solve the following proportions and make sure we show our work. So I tried to color coordinate what I was doing. Your previous math teacher may have talked about it differently. Instead of cross multiplying, they may have had mentioned like means and extremes, or maybe they talked about a butterfly or something along those lines. But we're going to stick with proportion and cross multiplying. So I'm choosing to start up here and go down over here. That's my choice. You can start elsewhere, and I'll show you that in example B. You're going to get the same results no matter whether you start with x and the 5 or the 10 and the 3. You get the same thing. So 5 times x equals 3 times 10. So I'm showing how I got 5x and how I got 30. And then from there, to undo this multiplication, I'm going to divide both sides by 5, and I get x equals 6. So on letter B, very similar, except instead of starting at the top, or the first ratio in the numerator, starting at the bottom, or the denominator in my first ratio. So I'm doing 6 times 8, and then equaling that to 3 times x. And I end up getting 16. Now example 4, same idea, but I have more than one term. So if you notice right here, and then right here in the numerator, I have this note that says put in parentheses. The reason you're putting that in parentheses is to make sure that you distribute the 7 to both terms. It's not just 7 times x, it's 7 times x and 7 times negative 2. You got to make sure that you distribute that 7 to both terms. So when I cross multiply, here's what I get on one side, and then I have 2 times 14 on the other side. So I end up with 28 equals 7x minus 14, because I distributed that 7. 7 times x, 7 times negative 2. And then I'm back to two-step equations where I have to solve. So I add 14 to both sides, and then I divided by 7 and got x equals 6. Letter B is very similar, just different numbers. So today we're focusing on what a proportion is and cross multiplying. So when we cross multiply, we are saying that we do have something that is proportional. So we're going to set them equal and cross multiply to get some sort of answer. If we are determining if something is equivalent or if they are the same, we would choose one of our 3 options, which would be to cross multiply, simplify each ratio, or divide, and that choice is up to you. So if you have questions, make sure you